This is SpaceTime, Series 23, Episode 2. Coming up on SpaceTime, Proton Aurorae discovered on Mars. It's all systems go for the maiden flight of ESA's new Vega C rocket. And Russian space tourism's back on the flight plan for Moscow. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered that a type of Martian aurora, first identified by NASA's MAVEN spacecraft in 2016, is actually the most common type of aurora occurring on the red planet. A report in the journal Geophysical Research Space Physics says this type of event, known as a proton aurora, may be able to help scientists track water loss from the Martian atmosphere. On Earth, aurorae are commonly seen as colourful displays of light in night skies near polar regions where they're known as the northern and southern lights, the aurora borealis and aurora australis. However, the proton aurorae on Mars happen during the day, and they give off an ultraviolet light which is invisible to the human eye but detectable by the imaging ultraviolet spectrograph instrument aboard NASA's MAVEN spacecraft. MAVEN's mission is to investigate how the red planet lost so much of its atmosphere and water, transforming it from a warm, wet world with a thick atmosphere that could have supported life to the cold, inhospitable, freeze-dried desert it is today. Now, since proton aurorae are generated indirectly by the hydrogen derived from Martian water that's in the process of being lost into space, these aurorae could be used to help track ongoing Martian water loss. The study's lead author, Andrea Hughes from the Embry-Riddle Aeronautics University in Daytona Beach, says the MAVEN data gathered over multiple years has found that periods of increased atmospheric escape correspond to increases in proton aurora occurrence and intensity. Different phenomena produce different kinds of aurora. However, all aurorae on Earth and Mars are powered by solar activity. Whether it be explosions of high-speed particles known as solar storms, eruptions of gas and magnetic fields known as coronal mass ejections, or gusts of the solar wind, a stream of electrically charged plasma that blows continuously into space at around 1.6 million kilometers per hour. For example, the northern and southern lights here on Earth happens when violent solar activity disrupts Earth's magnetosphere, causing high-velocity electrons to slam into gas particles in Earth's night-side upper atmosphere, making them glow. And similar processes generate the red planet's discrete and diffuse aurorae, two types of aurorae that were previously observed on the Martian night side. However, proton aurorae occur when solar wind protons, in other words hydrogen atoms stripped of their electrons by intense heat, interact with the upper atmosphere on the day side of Mars. As they approach Mars, the protons coming in with the solar wind are transformed into neutral atoms by stealing electrons from hydrogen atoms in the outer edge of the Martian hydrogen corona, a huge cloud of hydrogen surrounding the planet. And when those high-speed incoming atoms hit the atmosphere, some of their energy is emitted as ultraviolet light. When the MAVEN team first observed these proton aurorae, they thought they were a relatively unusual occurrence, but that's because they weren't looking at the right times and places. However, after a closer look, they found that proton aurorae were occurring far more often in dayside southern summer observations than initially expected. In fact, the authors found proton aurorae in some 14% of their dayside observations. And that increases to more than 80% of the time when only dayside southern summer observations are considered. Now, by comparison, MAVEN detected so-called diffuse aurorae on Mars in just a few percent of orbits with favourable geometry. And the other type of aurorae, those discrete aurorae we talked about, their detections are rarer still in the dataset. The correlation with the southern summer provided a clue as to why the proton aurorae are so common and how they could be used to track water loss. See, during the southern summer on Mars, the red planet is also nearer the Sun in its orbit, and it's a time when huge dust storms can occur. Summer warming and dust activity appear to cause proton aurorae by forcing water vapour high into the atmosphere. Then solar extreme ultraviolet light breaks the water into its components, hydrogen and oxygen. And the light hydrogen is weakly bound to Mars by gravity and enhances the solar corona around the red planet, increasing hydrogen loss into space. More hydrogen in this corona makes interactions with the solar wind protons more common, making proton aurorae more frequent and brighter. You're listening to SpaceTime. Coming up next, it's all systems go for the maiden flight of Europe's new Vega C rocket. And later, Moscow says Russian space tourism is back on its flight plan. All that and more still to come on SpaceTime. The European Space Agency says it will fly its new Vega C lightweight launch system on a maiden flight slated for March. The go-ahead follows successful hot-firing tests of both the P-120C first stage and the Zafiro 40 second stage solid rocket motors. Also, the new launch pad for the Vega C rocket is now being completed at the European Space Agency's Kourou spaceport in French Guiana. The existing Vega rocket has proven itself to be a reliable workhorse since its introduction back in 2012, carrying both single and multiple payloads into a range of low Earth orbits. The new Vega C will gradually replace the current version during this year. The Vega C increases the launch capacity of the Vega rocket from 1.5 to 2.3 tons. The maiden flight will be used to deploy multiple small satellites using Vega's new Small Spacecraft Mission Service, or SSMS, payload carrier system. ESA's Director of Space Transportation, Daniel Neuenschwender, says the new launch system has greater capacity and lower costs to orbit.
We just tested the Zafiro 40, which is one of the stages of Vega C. So today I'm happy to report that we tested basically all engines we have on Vega C. And now we go on the final pass. The final pass means that we need also to have combined tests of the launch pad together with the incoming new launcher, and this we will start in the next few months. So the first point is certainly the first stage, the P120, which is the first stage of Vega C. This one, with regard to the small sister Vega, you see it's an increased first stage, which gives more power. At the end, the performance goes from 1.5 ton to 2.3 tons overall in terms of delivery to orbit. And I should add a second point. It is that this P120C is common with Ariane 6. So in fact, we optimize the production in Europe of the first stages, which will be used on both launchers, Ariane 6 and Vega C. Coming back to these marvelous and efficient launchers, we have some upper stages, and a very important point immediately, it is the volume under the fairing. We have a much bigger fairing on Vega C. By the way, it is also a fairing which is produced in two parts only, which is also an enhancement in terms of production logic, but the customer doesn't care. The customer cares about the volume under the fairing. He cares about the delivery into orbit, how precise you can deliver your satellite or satellites, and of course what is the cost. So the third key aspect is that we drastically reduce the cost per kilogram with Vega C. We have a clear focus on the upper stages. So this is certainly also the key aspect for the evolution of Vega C. Now, a second parameter is the propulsion. And on the evolution of Vega, an engine which is methane-based, which will also allow to have a fully European developed upper stage, because today we fly with non-European components, and at the end of the day, I want to be sure that the autonomous and independent sovereign access to space is 100% European.
That's ESA's Director of Space Transportation, Daniel Neuenschwender. And this is SpaceTime. Coming up next, the Russian Federal Space Agency plans to modify a Soyuz capsule to carry space tourists, and we'll check out the night skies in January on Skywatch. All that and more still to come on SpaceTime. The Russian Federal Space Agency Roscosmos says it plans to modify a Soyuz capsule to carry space tourists on a trip to orbit. The spacecraft will have its flight controls reorganized so that it can be piloted by a single cosmonaut, instead of the usual practice of duplicating controls and spreading the workload across the usual three-person crew. The Soyuz will be modified as part of a partnership deal with American space tourism company Space Adventures. Roscosmos says the deal will see 2 space tourists fly to the space station in 2021. Between 2001 and 2009, 7 space tourists travelled aboard Russian Soyuz capsules to the International Space Station, one with deep enough pockets to do the journey twice. And deep pockets are needed. The first space tourist, Dennis Tito, paid over $20 million for his trip. And the price went uphill from there pretty steeply, with some reports quoting $200 to $250 million a seat. Russia was forced to halt its space tourist trips in 2010 due to the increase in the International Space Station's crew size from 3 to 6, needing the extra seats for expedition crew members. The problem was compounded even further when NASA mothballed the space shuttle fleet in 2011, forcing American and European crews to fly up on Russian Soyuz rockets. Now, with American crews about to start flying to the space station using SpaceX and Boeing spacecraft, it frees up some seating capacity aboard the Soyuz, and so Russia has its bookings list open again. Meanwhile, a private Russian company, Cosmos, is developing its own spacecraft which will compete directly against Blue Origin and Virgin Galactic for the suborbital space tourism dollar. The company plans on offering a 15-minute flight, carrying 6 people at a time, and providing between 5 and 6 minutes of zero gravity at the apex of its ballistic journey. It began testing equipment for its reusable rocket in May, with its first space tourists expected to be flying by 2025. And the price, well, just like Virgin Galactic, it's quoting around $200,000 to $250,000 a seat. Russia has launched a new geostationary weather satellite into orbit. The Electro L No. 3 meteorological satellite was carried aloft aboard a Proton M rocket equipped with the DM-03 upper stage from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan. The Electro L No. 3 satellite was placed into geostationary transfer orbit 6 hours and 37 minutes after launch. And time now to turn our eyes to the skies and check out the celestial sphere for January on Skywatch. January is the first month of the year in the Julian and Gregorian calendars. The name originates in the Latin word for door because January is the door to the new year and an opening to new beginnings. The month is conventionally thought of as being named after Janus, the mythical Roman god of beginnings and transitions. But according to ancient Roman farmers' almanacs, it was actually Juno who was the traditional god of January. For astronomers, January marks Earth's closest orbital position to the Sun, perihelion, which always occurs about 2 weeks after the December solstice. Now, the reason we have perihelion, and its opposite aphelion when Earth's at its most distant orbital position from the Sun, occurs because planets don't orbit the Sun in perfect circles, but rather ever-changing elliptical orbits. The shape of this orbit varies due to gravitational influences of other planetary objects. And in Earth's case, that especially includes our Moon, which is almost massive enough to be considered a binary partner. So, over a roughly 100,000-year cycle, Earth's orbit changes in shape from almost circular to far more elliptical. The difference is known as eccentricity. The next perihelion occurs on Sunday, January the 5th, 2020, at 18:47 in the evening Australian Eastern Daylight Time, when the Earth's centre will be just 147,091,144 kilometres from the centre of the Sun. That's at 2:47 in the morning US Eastern Standard Time and 7:47 AM Greenwich Mean Time. And as we said earlier, just 6 months later, about 2 weeks after the June solstice, Earth will be at its furthest orbital position from the Sun, aphelion. Okay, let's start our celestial tour in the northeast, looking towards Orion, the Hunter. It's one of the most easily identified constellations in the night sky this time of the year. And if you look near Orion, you'll see Sirius, the dog star, so called because it's the brightest star in the constellation Canis Major, the big dog. The name Sirius means scorching or brilliant, a clear reference to its spectacular brightness in the sky. As well as being one of the nearest stars to the Sun at just 8.7 light years, it's also intrinsically bright, some 25 times brighter than the Sun, and almost twice as bright as the second brightest star in the night sky, Canopus. By the way, a light year, that's about 10 trillion kilometres. The distance a photon can travel in a year at around 300,000 kilometres per second, the speed of light in a vacuum, and the ultimate speed limit of the universe. Sirius is the 5th closest star to the Sun right now, and it's gradually moving closer to our solar system. So it will steadily increase in brightness over the next 60,000 years, after which time the star system will begin moving away again, and it will gradually become fainter and fainter. But it will still continue to be the brightest star in Earth's night sky for at least the next 210,000 years. Sirius is a binary star system comprising a spectral type A main sequence white star called Sirius A and a small white dwarf companion, Sirius B, which orbits between 8.2 and 31.5 astronomical units away from the primary star. Now, an astronomical unit is a distance of about 150 million kilometres, the average distance between the Earth and the Sun, or if you prefer, you can think of it as 8.3 light minutes. And main sequence stars are those undergoing hydrogen fusion into helium in their cores. As well as being about 25 times more luminous than the Sun, Sirius A has at least twice the mass and size of our Sun. The Sirius system is between 200 and 300 million years old and was originally composed of two bright white stars. Sirius B, which was the more massive of the pair, became a white dwarf about 120 million years ago. We know that's the case because the bigger a star is, the quicker it consumes its resources. Now, a white dwarf is the stellar corpse of a Sun-like star. Having used up all its fuel supply fusing hydrogen to helium, it expands into a red giant as it begins fusing helium into carbon and oxygen. The thing is, Sun-like stars aren't massive enough to fuse carbon and oxygen into heavier elements, and so they turn off. Their outer gaseous envelopes float away in space as spectacular objects called planetary nebula, and what's left behind is a super-dense white-hot stellar core, about the size of the Earth, an object astronomers refer to as a white dwarf, which will slowly cool down over the eons of time. Sirius has played an important part in Earth's human history. 5,000 years ago, the ancient Egyptians saw Sirius as the god Anubis, lord of the underworld, who had the head of a dog and who invented embalming, the funeral rites, and guided one through the underworld to judgment, where he attended the scales during the weighing of the heart to determine one's fate in the afterlife. Later, Anubis was replaced as the lord of the underworld by Osiris, and Sirius came to represent the goddess Isis to ancient Egyptians. By carefully watching Sirius's movements across the sky, the ancient Egyptians determined that it would be visible every night for 295 and a quarter nights, followed by 70 nights of absence. And this observation allowed them to determine that the year was 365 and a quarter days long. And their calculations were accurate to within 11 minutes. The helical rising of Sirius also marked the annual flooding of the River Nile in ancient Egypt and the hot, sultry dog days of summer for the ancient Greeks. By the way, helical rising refers to the first time of the year when a star becomes visible above the eastern horizon for a brief moment just before sunrise. In Greek mythology, Sirius was the dog star, the canine companion of Orion the hunter. It's been claimed that the Dogon people of Mali in Western Africa have ancient stories describing the 50-year orbital period of Sirius and its companion white dwarf, which predate the white dwarf's discovery by modern astronomers. It's also been claimed that these legends were handed down to the Dogon people by ancient aquatic space travelers who told them of a third star accompanying Sirius A and B. But a report in the journal Current Anthropology has raised some serious doubts about whether the stars referred to by the Dogon were in fact Sirius A and its white dwarf companion, as senior Dogon have claimed that the story actually refers to a very different group of stars. Other researchers have pointed out that the Dogon could well have heard about the discovery of Sirius's companion and simply incorporated it into their mythology in 1893, when a French expedition arrived in Central West Africa to observe the April 16 total eclipse and probably discuss the new discovery. Okay, looking to the north this time of the year, just above the horizon, you'll find the bright yellowy star Capella, the brightest star in the constellation Auriga the Charioteer. Capella is the Latin term for a small female goat. The star's alternative name is Capra, which was more commonly used in classical times. Although it appears to be a single star to the unaided eye, Capella is actually a system of 4 stars in 2 binary pairs. The first pair comprises 2 bright yellow giant stars, both of which are around 2.5 times the mass of our Sun. Having exhausted their core hydrogen, both stars have cooled and expanded out to become giants, moving off the main sequence. Designated Capella AA and Capella AB, they're in a very tight circular orbit, some 0.76 astronomical units apart, orbiting each other every 104 Earth days. Capella AA is the cooler and more luminous of the two, with some 78 times the luminosity and 12 times the radius of our Sun. Known as an aging red clump star, Capella AA is fusing helium into carbon and oxygen in its core. Capella AB is a slightly smaller and hotter subgiant. about 73 times as luminous and almost 9 times the radius of our Sun. It's now in the process of expanding out to become a red giant. The Capella system is one of the brightest sources of X-rays in the sky, thought to come primarily from the corona of the more massive giant. The second pair of stars in Capella are located around 10,000 astronomical units from the first pair. They consist of two faint, small, and relatively cool spectral type M main sequence red dwarf stars. They're designated Capella H and Capella L. Almost directly overhead this time of year, a celestial position known as zenith, we find Canopus, the second brightest star in the night sky after Sirius. It's located some 313 light-years away in the constellation Carina the Keel. Canopus looks incredibly bright because it's huge. It's a spectral type A blue star, with some 10 times the mass, 71 times the diameter, and 10,000 times the luminosity of our Sun. Canopus is a bright source of X-rays, which are probably produced by its corona, magnetically heated to several million Kelvin. The temperature has likely been stimulated by fast rotation combined with strong internal convection currents percolating through the star's outer layers. No star closer than Canopus is more luminous than it. In fact, it's been the brightest star in Earth's night sky during 3 different epochs over the past 4 million years. Other stars, such as Sirius, appear brighter for relatively temporary periods, during which time they're passing the solar system at much closer distances than Canopus. About 90,000 years ago, Sirius moved close enough that it appeared to be brighter than Canopus, and as I said earlier, it'll remain that case for at least another 210,000 years. But in some 480,000 years' time, Canopus will once again become the brightest star in our night sky, and will remain so for a period of at least another 510,000 years. In Greek mythology, Canopus was the helmsman and navigator for the fleet of Menelaus, king of Sparta, which was sailing back from the Battle of Troy. Canopus is said to have died when the fleet arrived at the port in Alexandria, Egypt, and so a star which became visible on the horizon was named after him. The nautical theme's understandable, because it's after all in the constellation Carina, which represents the keel of the boat Argo, used by Jason and the Argonauts in their quest for the Golden Fleece. And located nearby are the vessel's sails, represented by the constellation Vela, and the roof of the boat's rear cabin, known as the poop deck, which is represented by the constellation Puppis. Canopus also forms part of the stellar association, or astrum, known as the False Cross, which straddles the constellations Carina and Vela the sails, and is often confused with the real Southern Cross, or Crux. This time of year, the Southern Cross is upside down and low down in the southern skies during early evening. In fact, for our listeners north of Brisbane, the Southern Cross will be hidden by trees and buildings on the horizon most of the early evening. But later on, as the Earth turns, the Southern Cross will rise above the horizon in the south-southeast for our northern listeners and appear to be lying on its left-hand side. In fact, most of the brightest stars visible in the night sky are visible during January nights. Sirius the Dog Star is the brightest, followed by Canopus, the navigation star. The third brightest is Alpha Centauri, one of the 2 pointers showing the way to the Southern Cross, low in the south. The fourth and fifth brightest stars, however, Arcturus and Vega, aren't visible in the southern hemisphere during January. But the sixth brightest, Capella, is visible just a fist width above the northern horizon, and the seventh, Rigel, marks Orion's knee. Next is Procyon, the little dog, in 8th place. 9th is Acima at the end of the river Eridanus. And finally, Betelgeuse, better known to most people these days as Betelgeuse, is Orion's shoulder and the 10th brightest star in the night sky. So that's 8 of the 10 brightest stars in the night sky, all visible at the one time on warm summer evenings here in the southern hemisphere. January plays host to one primary meteor shower, the Quadrantids. Most meteor showers radiate from recognizable constellations like Leo's Leonids, Gemini's Geminids, or Orion's Orionids. But the Quadrantids are meteors that appear to radiate from the location of the former Quadrans Muralis constellation. See, back in the early 1920s, the International Astronomical Union divided the sky up into 88 official constellations. Trouble is that left more than 30 other historical constellations which didn't make the cut, and the Quadrans Muralis area of the sky now lies within the boundaries of the official constellation of Bootes. The radiant point of this shower is near the Big Dipper, between the end of the handle and the quadrilateral group of stars marking the head of the constellation Draco. The Quadrantids are usually one of the year's most spectacular meteor showers, with up to 80 meteors an hour. They're best seen from the northern hemisphere, but unlike other meteor showers which tend to peak for a day or two, the Quadrantids usually only peak for a couple of hours. Also, while most meteor showers are produced by the Earth passing through debris trails left behind by comets, the quadrantids are one of just 2 meteor showers produced by asteroid debris. They're associated with the asteroid 2003 EH1, which is thought to be the remains of a cometary nucleus that fragmented and broke apart centuries ago. EH1 still circles the Sun in a 5.5 Earth-year-long elongated comet-like orbit which extends out beyond Jupiter. The progenitors thought to have been the comet C1490Y1, which was first observed by Chinese, Japanese and Korean astronomers 500 years ago. It was classified as an asteroid when it was discovered by the Near-Earth Asteroid Telescopic Survey in 2003. By the way, the only other major meteor shower known to be associated with an asteroid are the Geminids, which occurred last month in December. They're caused by debris from the asteroid 3200 Phaeton, which is also thought to be the remains of a comet. Jonathan Nally, editor of Australian Sky and Telescope magazine, joins us now for the rest of our tour of the January night skies.
G'day Stuart, well, night sky. We'll begin with the evening sky like we always do. So the Southern Cross, it's more or less still upside down at the moment, low down on the southern horizon for most people in sort of most southern temperate latitudes like Sydney, that sort of thing. Further south you get a slightly better view. As the night goes on though, as the Earth turns on its axis, the Southern Cross will get higher and higher in the southeast and it will end up sort of lying on its left-hand side late at night before you go to bed. The Milky Way is stretching right across the sky from south to north at the moment, right across the sky, and its star field's got some fantastic constellations, great deep sky objects. Starting down at the south is the Southern Cross, of course, which always looks great, and right next to the Southern Cross in the same sort of area, you've got Carina, Vela, Puppis, and Canis Major, all those magnificent constellations through the Milky Way. Just get a pair of binoculars onto those and just sweep through the Milky Way and look at all the star clusters and things you see. It's just really tremendous. And if you keep going north, you'll get to Orion, and keep going a bit further, you'll get to Gemini and Taurus. All of these constellations got great stuff to see. I mean, we've spoken about this before, the Pleiades, or Seven Sisters star cluster, up there in the northern part of the sky for us here in the south. It's just magnificent. It looks great to the unaided eye, just this little cluster of twinkly stars if you get a nice dark spot to see them from. But get a pair of binoculars onto it. It's just tremendous. There are
visitors from the northern hemisphere are just so flabbergasted when they see what we've got down here in the night skies.
Oh, yeah. Well, I was reading a history of an American astronomer called Bart Bok recently. And Bart Bok, very famous fellow, and he actually came out and ran Mount Stromlo Observatory down near Canberra for 10 years. And he famously said, he went back to the States or something, he famously said, all the best stuff's in the south. and he's quite right in that sense. Well, there's lots of good stuff in the north too. But anyway, so yeah, the Pleiades, Seven Sisters, some other star clusters around that area, around Taurus as well. Back down the south again, high up in the south, we've spoken of these before as well. These are the Magellanic Clouds, the two nearby galaxies, small and large one. You need dark skies to see these. You won't see them from standing under a street light in a city environment because they're quite faint. And they're quite large, so they've got a low sort of surface brightness. But if you get yourself to a dark spot and you let your eyes get dark adapted for 20 minutes or so, you'll be able to pick out these two cloudy galaxies with no trouble at all. They really look quite amazing. Now, turning to the planets, what have we got? So Mercury, very low on the horizon at the moment during January. I really wouldn't even bother trying to look for it. Same thing in February. It's going to be low on the horizon. But March, when March comes around, we're going to have much better viewing of Mercury, the innermost planet. Next one, Venus, nice and bright in the west after sunset. Can't miss it. Big, bright-looking star thing. It's actually a planet, of course, but it looks like a star. Really big and bright. And it's
that means we're going to get lots and lots of UFO reports, undoubtedly.
You get lots and lots of people saying, what on earth is that big bright light? I wasn't there last night. And you say, well, yes, it was. You just didn't notice it. And because it's in the west, you get a lot of people in various cities who, just the way the cities are laid out, when they're driving home from work in the afternoon, very often they're going west, and the sun's gone down. They see this big bright light. And they go, what on earth is that? Well, it's just Venus. It's going to be really good, actually. It's going to be in the evening skies out to the west all the way through till May. So plenty of chances to have a look at Venus. It's really, really good. What have we got next? Mars. Okay, well, to see Mars at the moment, you're going to have to be an early riser or a night owl, as it's in the eastern sky before dawn. But it's a good sight to see as well. It just looks like a reddish, medium brightness star. And later in the year, we're going to have what's called opposition, which is when Mars is going to be on the opposite side of the Earth to the Sun from the point of view of someone standing on the Earth. They call it opposition. And that's the best time to see Mars. So that's coming up in October. We'll get to that in a few months' time. Jupiter, it's low on the eastern horizon before sunrise, just looks like a bright star. It'll get a bit better as the months go on. Saturn, unfortunately, is around the other side of the sun this month, so we're not going to be able to see it. It'll be back in our pre-dawn eastern skies in February. Finally, Stuart, there's going to be an eclipse. We've got an eclipse coming up in January. Yeah,
yes.
January the 11th, visible from Australia, Asia, Europe and Africa. It's going to be in the early hours just before dawn for people in Australia. But actually, don't be surprised if you don't really notice it. I mean, if no one told you it was on, you probably wouldn't notice it, because it's going to be what's called a penumbral eclipse. The Earth, or any body really, say body in the term of a planet, any planet has two parts to its shadow. The darker umbral part, that's in the middle of its shadow, and surrounding that you've got the penumbral part of the shadow, which is lighter. The shadow is not quite so dark. And so the moon is going to move into the penumbral area of the Earth's shadow, so it won't go completely dark. It might just go a little bit darker than normal, just as it sort of goes through this penumbra. If you didn't know it was happening, you might not even notice it. So, but anyway, it's still a good thing if you've got nice clear skies on January 11 before dawn. Get out and have a look, see what you can see. It's always good to try and catch an eclipse because they don't come around every month, and often when they do come around, it's cloudy, so you miss it. So you can go for years without seeing one, depending on what the weather's like.
And of course, we've got perihelion coming up on the 5th.
That's right, perihelion, Earth's perihelion. Perihelion meaning closest point to the sun in our orbit. And this is one of those things where people get confused a bit about, what causes summer. So, or winter. So perihelion, we're going to be closest to the sun in January. So does that coincide with summer in the southern hemisphere? Well, it coincides, but it's not the cause of it because, of course, it's winter in the northern hemisphere, so why wouldn't it be summer up there too if the cause of summer was being closer to the sun? The cause of the seasons, of course, is simply the tilt of the Earth's axis. But, yep, for us in the southern hemisphere, we're going to have closest approach to the sun around about the same time as we have summer.
That's Jonathan Alley, the editor of Australian Sky and Telescope magazine. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcasts, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web that I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram. On Facebook, just go to www.facebook.com/SpaceTimeWithStuartGary, and you can also find us on the SpaceTime with Stuart Gary YouTube channel. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.